Good morning, students. I am Ramesh Chandra, Assistant Professor, EC Department, Vishnu Institute of Technology. Today we are going to learn one more experiment in the Lika lab. The experiment name is Frequency Response of Active Band Pass Filter using IC741 Operational Amplifier. Our aim is to design active band pass filter using IC741 Operational Amplifier and plot the frequency response of it. The apparatus required for this experiment is breadboard, function generator, CRO, dual mode power supply, connecting wires and probes as required. The components required to do this experiment is resistors. We need 1 kilo ohm resistors, 5 numbers, 4.7 kilo ohm, 1 number. Coming to the capacitors, we need 2 capacitors, 0.1 microfarad and 0.01 microfarad. And also we need IC741 operational amplifiers. 2 IC741 operational amplifiers are required. This is the IC741 pin structure. How we will identify the pins in the IC741 is shown here. If you observe, it will have a parabolic shape cut here. On the left hand side of this parabolic cut, pin number 1 starts from there. Pin number 1 is offset null. Below that, you will have pin number 2 and 3. These are input pins for the op-amp, inverting input and non-inverting input. Pin number 4 is power supply, negative power supply minus VCC. Then if you take U-turn from that point, you will have pin number 5, that is also offset null. Then pin number 6, from pin number 6 we will take output of the operational amplifier, and pin number 7 is positive power supply plus VCC, and pin number 8 is NC, not connected, it is a dummy pin. Here we mainly use 5 pins, input pins and output pin, as well as 2 power supplies, positive power supply and negative power supply. Then coming to the circuit diagram, this is the circuit diagram. If you observe here, you will have 2 sections. One is first order high pass filter and another is first order low pass filter. If you cascade first order high pass filter with first order low pass filter, it works as a active band pass filter. You can observe 2 IC741 operational amplifiers here. Coming to the theory, mainly band pass filter is nothing but a frequency selector. It is used to select the desired range of frequencies. Means it will allow only certain range of frequencies, and it will attenuate the other frequencies. It will only allow the frequencies between FL and FH. FL is known as lower cutoff frequency, FH is known as higher cutoff frequency. The frequency band in between FH and FL, we will call it as pass band, and it is also called as bandwidth of that filter. The center of the pass band, we will call it as FC, center frequency, or resonant frequency, or peak frequency. You will have maximum pass band gain at the center frequency. Always FL must be less than the FH. The pass band is also called as bandwidth of the filter. The gain of the filter is maximum at the center frequency or resonant frequency. That voltage gain, we will call it as A maximum. This picture shows how we are designing active band pass filter by cascading high pass filter followed by low pass filter. The frequency responses for high pass filter and low pass filter as shown here. If you add these two, the band pass filter frequency response characteristics are looks like this. FL is the lower cutoff frequency, FH is the higher cutoff frequency. In between frequencies will be allowed by this band pass filter. Beyond this FL and FH, the frequencies will get attenuated. This is the frequency response for the active band pass filter. On the x-axis we are taking frequency, on the y-axis we are taking the voltage gain in dB scale. This is the pass band, this is the stop bands. The difference between the highest cutoff frequency and lowest cutoff frequency will define the bandwidth. After doing the experiment in the lab, we need to fill this table. The main parameter is input signal peak to peak voltage, which will take it as a 2 volts peak to peak voltage. And frequency will change, input frequency from 100 Hz to up to 30 kilohertz. Because we got a higher cutoff frequency in theoretical calculations, it is around 15 kilohertz. That's why we are taking up to 30 kilohertz. At least we need to take 15 to 20 readings in between 100 Hz to 30 kilohertz. Then we can plot frequency response on the logarithmic graph easily. If you apply the input sinusoidal signal with 2 volts peak to peak voltage with certain frequency, at the output you will get the sinusoidal waveform with amplified version or attenuated version. Then note down the peak to peak voltage, that is called output voltage. Note down here. Then we know V0 and Vi, that is output voltage and input voltage. From that we can calculate gain V0 by Vi. From that we will convert that into dB scale by using this formula 20 log V0 by Vi. Then we will get gain in dB scale. By using these readings we will plot the frequency response, and from that we will try to know the lower cutoff frequency, higher cutoff frequency, and as well as bandwidth and maximum voltage gain also. These are the theoretical calculations. We are calculating the cutoff frequencies, lower cutoff frequency and higher cutoff frequency. Lower cutoff frequency will calculate from the high pass filter section. In the high pass filter section, we are using RC values as follows. R is 4.7 kilo ohm, C is 0.1 microfarad. From that, if you calculate lower cutoff frequency by using this formula 1 by 2 pi RC, then we are going to get this value 338.62 Hz. Then we are calculating the higher cutoff frequency from the low pass filter section. The RC values are as follows. R is 1 kilo ohm, C is 0.01 microfarad. By using this formula, if you calculate the higher cutoff frequency, it comes out to be 15.92 kilohertz. From that, you can calculate the bandwidth. The difference of higher cutoff frequency and lower cutoff frequency will give you the bandwidth. Then maximum voltage gain, we are calculating A maximum. A maximum is equal to A1 max and A2 max. A1 max is nothing but it is high pass filter maximum voltage gain. A2 maximum is nothing but low pass filter maximum voltage gain. By using this formula, if you calculate, it comes out to be 4 volts as the maximum voltage gain. Now we will go to the lab and see how the frequency response comes for the active band pass filter. From that we will calculate the lower cutoff frequency, higher cutoff frequency and bandwidth, as well as we will see the maximum voltage gain. Thank you. Good morning students. Today we are going to learn how to perform another experiment in the Leica lab. The experiment name is frequency response for the active band pass filter using IC741 operational amplifier. Band pass filter is a frequency selector. That means it allows only certain band of frequencies and it will attenuate the other frequencies. The band, which we will call it as pass band, and it is also defined as bandwidth of the filter. The bandwidth is defined by the two cutoff frequencies. One is lower cutoff frequency FL, another is higher cutoff frequency FH. The difference between these two we'll call it as bandwidth or pass band of that filter. The center of the pass band we'll call it as FC, that is center frequency or resonant frequency. At the resonant frequency you will have maximum pass band gain. If you see the circuit diagram of the band pass filter, it looks like this. This circuit contains two sections. Initial one is first order high pass filter section. It is cascaded with first order low pass filter section. If you cascade high pass filter with low pass filter, it will work as a band pass filter. In the circuit diagram you can observe two ICs and different resistors and capacitors. I have connected the same circuit on the breadboard here. On the breadboard you can observe two IC741 operational amplifiers as well as different resistors and capacitors. And we need equipment, dual channel power supply and function generator and as well as CRO. Now for this band pass filter, I am applying input signal taken from the function generator. Here I have set sine wave with 1 kHz frequency, 2 volts peak to peak voltage. You can observe that in the CRO, it is the input waveform. I have set as 2 volts peak to peak voltage and frequency is 1 kHz. This input I am applying it to the first IC of the third pin of the IC741, which is non-inverting input. Then and also I am applying 15 volts DC power supply to this circuit. The positive VCC I am applying it to the pin number 7 of both ICs, and I am applying negative VCC to the pin number 4 of both ICs. Then I need to observe the output of this band pass filter. The output is taken from the 6th pin of the second IC and it is given to the CRO. You can observe the waveform. It is amplified by this filter. Usually active band pass filters, they will allow certain band of frequencies and also those band of frequencies will also be amplified. That's why we will call it as active band pass filter, because we are using active devices like transistor or operational amplifier. Now I am changing the frequency there. Initially I set 1 kHz. Now I am changing frequency from 100 Hz to 2 Now we are changing input sine wave frequency from 500 Hz to, for 500 Hz, if you are increasing frequency, you can observe the output waveform how it is changing. The peak to peak voltage, it keep on increasing and reaches at some point peak voltage, and if you increase further at 35 kilohertz, you can observe how waveform is keep on attenuating. Take all the readings for different frequencies and note down in the given table. Note down the different values in the following table. Input voltage you need to note down. Input voltage we have taken 2 volts peak to peak. It is a sine wave. Change the frequency for the input from 100 Hz to up to 30 kilohertz. At least you need to take 15 to 20 readings to plot the frequency response on the logarithmic graph. For different frequencies, note down the output voltage V0 for 100 Hz, for 500, for 1 kHz, for 3 kHz, like that. You need to observe the output voltage and note down here in this table. After getting the output voltage for different frequencies, calculate the gain. Gain we can calculate from this formula V0 by Vi, that is output voltage by input voltage. You will get the different readings like this. After calculating gain, convert gain in dB scale by using this formula 20 log V0 by Vi. You will get the different readings like this. Plot these readings on the logarithmic graph. You will get the frequency response for the band pass filter like this. If you observe from lower frequency, the gain keep on increasing and reaches the peak value at some point, and it is constant for pass band, and again if it crosses the higher cutoff frequency, the gain keep on decreasing. From peak amplitude, if you take down minus 3 dB point and slice on the graph, it will cut on the lower frequency side at one point, on the higher frequency side on the other point. You will get the FL and FH. Note down these 2 points, lower cutoff frequency and higher cutoff frequency. From that we can calculate the bandwidth. Bandwidth is nothing but the difference between the higher cutoff and lower cutoff. These are the readings we observed from the plot. Lower cutoff frequency comes as 330 Hz. Higher cutoff frequency it observed as 16 kHz. If you calculate the bandwidth, it comes out to be 15.7 kHz. These are practical observations taken from the frequency plot. The theoretical calculations we will see it in the PPT presentation, how we will calculate the theoretical values. This is how we will do the active band pass filter using IC 741 operational amplifier. Thank you for listening this video demo. Thank you.